Great. Whoa. How's it going, everybody? My name is Paul. Thank you so much for coming to the session. Myself and Tsuri are going to be taking you through a bit about how we manage DDoS and a few things on our services and features that you guys could be benefiting from. Just in terms of introductions, I am the manager for the threat research team that looks after, it's in our perimeter protection organization. My team spends a lot of effort understanding the threats that are coming into our perimeter and working backwards from that and turning it into actionable intelligence for us that we use to protect our infrastructure and build better features. Zuri?
Yeah, and my name is Tsuri Tamam. I will be holding a competition on correctly pronouncing my name at the end of this. I'm a solution architect specialist dealing with edge services, namely CloudFront, Edge, and Shield. Coincidentally, I'll be mentioning all of these on the talk today.
We've worked a lot in the past together. That's why we're wearing the same clothes today. But Tsuri and I have, we have done a lot of stuff in the past. He has spent a lot of time helping customers implement our services. That's what he's going to be talking about, what you can do to protect against DDoS and providing you some examples. And I'm going to run through a quick look at the current affairs, the trends that we're seeing, and then a bit more detail on what are the mechanisms we've implemented to protect the availability of infrastructure. It is a 200-level talk, but I just want to say that it's a 200-level talk on average. So there are some parts here that might be technical and go into some of the detail, and there are others that will be higher level, but hope you enjoy. So let's take a look at, firstly, what are we seeing? What you see here is a graph showing the number of DDoS events we're detecting and mitigating. So you can see it's pretty flat. Over the years, we haven't seen a massive increase. It's probably like just under the million mark, million DDoS events every year. You shouldn't be fooled here. Like this, DDoS is definitely here to stay. It's not going anywhere. And there is still a lot of innovation going on in the space. But as we take a step back or look a bit more into the detail, we can break down these DDoS attacks that we're detecting into two groups. The first group is infrastructure layer events. So here we see an obvious downward trend. Now, infrastructure layer events have been around for a very long time. They were the first type of DDoS that was leveraged. And these are typically DDoS events that are abusing the lower networking layer protocols, right? So TCP is one protocol where bad actors send loads of SYN packets to establish a connection and overwhelm resources by forcing them to open up many connections. There are UDP reflection attacks where bad actors are using the UDP protocol. They are spoofing source IPs in there, and they're using that as a way to attack. This is less common today, and it's a very easy problem to solve. And we've been doing this for years, maintaining the availability of our infrastructure. Where all the innovation is happening is on the application layer. And for the first time, the majority of the DDoS attacks that we've detected and mitigated are at this layer. This is now the most common way for DDoS to take place. And the application layer is another way of saying the HTTP layer or the kind of web traffic layer. So these attacks manifest in just large volumes of web requests or HTTP requests. So web request floods, 56% in this year to date of all the DDoS events that we've detected, and it's growing at this rapid rate of 40% year over year. I want to talk now about some of the things that we've seen in this space, because this is where we spend our time, this is where we spend our energy researching and collecting intelligence on and building features for. The first thing that was of interest was in Q3, there was the CVE that was publicly announced. Some of you might have had to deal with this. It's called the Rapid Reset Vulnerability. And we saw an attack peak at 155 million requests per second. The last time I stood on the stage at reInvent, I think I said 5 million was the peak, and now we're hitting 155 million. So this is a new vector, and it's a abuse of the HTTP 2 protocol, which had so many benefits on top of HTTP 1, except it opened the door for this type of vulnerability. And in September, and over August, September, we saw these attacks. Our customers who were running on CloudFront were automatically mitigated and protected from these attacks. But it's a very interesting vector that I want to quickly spend some time talking on. So here's a quick graph on trying to explain how this reset vulnerability works, this rapid reset vulnerability. So in HTTP 1, you have like an HTTP session that you sending a request, and over a single session, you send a request, and you have to wait for the response. And so you could achieve high volumes of request floods if you had a lot of compute and you distributed out lots of sources, and you could send lots of web requests. You had to create a lot of HTTP sessions, and you had to send. You could send at a high rate, right? So that's how we got to like 5 million requests per second. But now with the HTTP 2, the benefit is that you can pipeline requests, right? You don't have to wait for a response. In a single session, you can send many requests, and it allows you to achieve higher rates of HTTP requests. And so this is obviously a DDoS vector, and the rapid reset is interesting because if you put in the reset request, you're saying request, reset, it actually causes a lot of load on the receiving server to log all of these connections, log the reset, and it doesn't even have, the client is not even waiting for a response. So it was a really powerful vector. And today we have mitigations and protections in place in CloudFront and other web application layer services. That vector also abused what we refer to as proxy abuse. This, our intelligence tells us that 88% of DDoS attacks at the application layer are leveraging proxies. And this is a very interesting space because if you, on the internet out there, there are a lot of just proxy servers. Proxy servers, if you don't know, are just servers that receive HTTP requests and forward them on to wherever you wanted them to go, right? It's a very clever tactic for students who need to get out of the university network, who want to browse things that they're not supposed to be browsing. They go through a proxy, so their traffic is not being monitored. There are thousands of these things out there on the internet, and they are open. Open means that you don't need to be authenticated to use them. That means anybody can use them. You can use them for good reasons. You can use them for bad reasons. Bad actors are using them to launch DDoS attacks because they obfuscate the real IP that's from the originating server. So they build these proxy drivers, which is basically just a large compute machine that's running 50 lines of Python code, and it's sending loads of requests to a list of like 10,000 proxies on the internet. And so if you're the target of that traffic, all you are seeing is proxy IP addresses. And this is, as I said, 88% of all application layer attacks are leveraging this. This is distinctly different to a botnet. Just so that there's clarity, botnets require you to install malware or a software program on a compromised instance. And then those instances are controlled by command and control servers, so that the attacker only has to send a command from the control server to the bots. These bots obviously can do HTTP attacks, but it's just important to say that we track botnets and proxy networks as separate issues. All right, let's dig into a bit about how we deal with DDoS. Starting off with the scale at which we need to do this is crazy. Across our global network of 600 points of presence in all those 50 countries, we're seeing thousands of DDoS attacks every day. right? So these attacks are just coming in coming in different formats, different ways, different endpoints, different areas of the globe. And it's really forced us to think differently about how to deal with DDoS. And that's why my team exists. So this is our mission. We have signed up as a team to say that we want to protect Amazon infrastructure by making AWS an unattractive target for cyber attacks. We've realized that you cannot get rid of DDoS. DDoS is always going to be there. There are 10 different motivations at least for why you'd want to do a DDoS attack. And that's not going to go away. But what we want to do as a team is build features that make it an unattractive place to target AWS. And I'm going to get into that in detail in a bit later in this talk. What's challenging here is that we're not just protecting a simple application. We're protecting this global infrastructure with the scale that we just looked at. If it was like this, it would be perfect. One entry point to your application, you understand what traffic you expect, you know where that traffic's going, you can scale where you need to scale, and it's fairly easy to monitor and manage. If this was our job, if this is what we were protecting, it would be much easier. However, in reality, our job is a bit more complicated than that. We've got multiple entry points. You can send traffic to AWS through a CloudFront distribution. You can send it through a global accelerator. You can send it to your NLB that's open to the internet. It can come from a satellite. It can come from all over the place. And we have to think about how do we protect each of these entry points and understand what traffic is DDoS and what is not. There's different routes this traffic can take. There's congestion points all over the place. And we want to try and avoid these so that we can maintain availability. And so this is why the problem that we're trying to solve is so interesting. It's because there's so many variables at play. We do this by integrating Shield into our network. Shield is our DDoS protection product. And it's got an external feature or external service called Shield Advanced that Zuri's going to talk about. But a lot of what we do is we work with other service teams like the ELB or the load balancing team, CloudFront, Global Accelerator, and we embed our detection and mitigation and learning capabilities in those services so that no matter the entry points, we're able to monitor for anomalies, mostly using NetFlow data, and we use that and we turn it into mitigations, and we own those systems that place mitigations that block or rate limit or scale and deal with the traffic. So this is our approach. And so I want to talk about 4 key things, 4 key areas that I think are very important in our strategy for dealing with DDoS. I should probably add a 5th one for Gen AI after this week, but maybe that'll be for the next talk. So default mitigations. Default mitigations are mitigations we have in place that are always on. They're there. If you're just using the service, you're benefiting from the default mitigation. For example, if you're using Amazon CloudFront, you're not expecting traffic that's not web-related, right? So immediately, if you're on CloudFront, we are immediately taking care of, it was like 44% of the threat landscape. Anything that was in the infrastructure layer bucket, those events are all taken care of if you're using CloudFront because we know what traffic you're expecting and we can drop all the bad stuff. So that immediately is improving your security posture. So that's one mitigation tactic. Another is anything pretending to be AWS gets dropped. All right? We see a lot of this. We see traffic coming into our network saying, hey, I'm AWS. And we're saying, no, we're AWS. You're not AWS. And so we can identify those packets. We can drop them because if we let them into our network, it results in what's called a reflection attack. So it's traffic coming in, and then it's reflecting off an endpoint and going to the spoofed source. That is a vector that we now are protecting you against by running these ACLs or like filtering rules on our border network. All right. Another area that we by default protect from is the backbone network. So on our backbone network, we have default mitigations in place that pick up packets that match DDoS signatures. This is mostly infrastructure layer DDoS. So where I spoke about earlier, like infrastructure layer DDoS is quite well understood. It's easy to detect. For example, a protocol and a source port combination is typically a way that you could identify DDoS. And we use that and we place it on our network so that if there are volumetric spikes that match that signature, those packets are immediately dropped, which means it frees up capacity for the legitimate traffic. And then lastly, another default mitigation we have is we rate limit known offenders. This is part of an output from my team. We are learning from every DDoS attack on our network. And at the layer 7, the application layer, which is what I spoke is where all the fun is at, we track sources that send us traffic. All right? So most of these sources are proxies. I mentioned earlier, 88% of these attacks come from proxies. And we keep track of the proxies that are abused. All right? So basically, we're replicating the lists that bad actors are using, and we're applying these known offender mitigations to our CloudFront POPs and global accelerator hosts, which means that what we know is bad is automatically protecting you if you're using these services. All right. The next thing we get into is protocol-aware mitigations. So here we're really understanding how these protocols are working, and we're building features that prevent abuse of those protocols. Intelligent TCP control. So here we've built a feature called SYN proxy. This is an internal capability that handles the TCP connections. I mentioned earlier SYN floods, right? SYN floods are where bad actors just send a lot of SYN packets. And if you're not familiar with the TCP protocol, there is this thing called a TCP handshake, which is just how a connection is established. So SYN packets like, hey, I want to talk to you. Then you respond back with a SYNAC going, OK, cool, let's talk. And then you go, OK, great, let's do this. And then you start with all the traffic, and you send the requests, the web requests. Our SYN proxy technology is managing this connection, this handshake, on behalf of the service and on behalf of your applications, so that when the connection is established, it gets sent through to your backend, and you can receive the web request. Bad actors, this is specifically designed to prevent bad actors from doing this. They just send SYN packets, and then we respond with a SYNAC, and then they don't respond. If we didn't have SYN proxy, your application resources would be dealing with all of these SYN packets. And that's the power of using our edge services, is that our SYN proxy technology on CloudFront and Global Accelerator is managing this vector entirely for you. Another way we do this is on the DNS side. For Route 53, we have this packet suspicion management technique that we use. Basically, we have 8 buckets. P0 is the most important. P7 is the least important. And as traffic comes in, we prioritize it accordingly. This means that the purple line is the total capacity that this POP can handle. So if the traffic is below the total, it gets distributed between the buckets, and we don't have to drop anything. However, if the traffic that we're receiving is more than what we can cope on that POP, then we're deprioritizing the packets in the lower priority buckets so that we can ensure that the higher quality traffic is being passed through. This is a way that we are managing capacity and availability of our Route 53 POPs. And it works really well when you tie in suspicion scoring with these prioritizing these buckets, because we can score packets that look like cache busting attacks, put them into the low priority buckets, and then drop those things really easily. All right. So a good question that I get often from customers is, what about DDoS or abuse coming from within the AWS network? This happens. I don't want to stand up here and lie to you and say that there's nothing bad on the AWS network, because sometimes customer instances are left insecure. They don't have the right security policies in front of them. They're running software that's unpatched, and they're vulnerable. And so bad actors turn them into bots. And so you end up in a situation like this, where a bad actor has built a botnet. He's compromised infrastructure outside of our network and inside of our network. And these, in this case, we see a DDoS attack targeting a victim, an endpoint that's on our network, but the traffic towards that endpoint is coming from outside of our border, as well as from inside of our border. And so I've already mentioned some of the techniques we use to protect the inbound traffic through AWS Shield. But we also have monitoring on traffic heuristics for instances running and compute capacity running on our network. We're able to pick up abuse automatically and then isolate those instances. And so how we do that is we automatically kind of like lock down that instance so that it can't send traffic on the abusive port that it's been using. And we only allow inbound SSH, which means that our trust and safety organization can then reach out to you as a customer and work with you to say, hey, like something was being abusive on your instance. Let's figure out what it is and let's clear it up and then remove the isolation. So this automatic mitigation or abuse mitigation is part of the whole DDoS story, because the quicker we detect abuse, the quicker we can help you recover your instance, and the quicker we free up the availability of our network. One technique we found super effective is botnet disruption. Now, this is what I was talking about earlier. This is going down that path of our mission to disrupt and make AWS an unattractive target. When we learn about a botnet, we can trace back the traffic from the bots to the command and control server, all right? Now, when you figure out where the command and control server is, a very easy way to stop this east-west traffic, that's when you get traffic from AWS to AWS, is to prevent the bots that are on our network, potentially, to not communicate with the C2. Right? Because if they can't communicate with the C2, they can't get the attack command, they can't participate in any attacks. And so we place a network layer mitigation that black holes any traffic from that C2 on our network. That means that if there are compromised bots running on EC2 in a region, they're unable to receive the attack command, and they're unable to participate in an attack. So even when the victim is not even on AWS, it's hosted somewhere else, a portion of the botnet is disrupted, right? And that means that we're making AWS an unattractive place, because by using our infrastructure as your botnet, we're able to trace back and figure out where your C2 is. And we even take further actions in this that I'll go into a bit just after this. All right, I'm actually going to go into it right now. We work, part of our team is to work with outside companies to do takedown requests. Now, a takedown request is not my security engineer knocking down someone's door going, go to, taking down the bad actor. It's not like that. This is us reporting abuse to ISPs or domain registrars saying, hey, here's an IP address, here's the data that we have that's showing you abuse from this IP. We want you to please take it down. And we've seen this to be super effective. For example, if you take down a C2, if you work with another hosting provider, by the way, we do this automatically on our network. This is us working with external providers. And we say, hey, here's the data. They take down the C2. We're actually forcing the bad actor to go and rebuild their infrastructure somewhere else. right? So it drives up the cost, it drives up the barriers of launching DDoS attacks for bad actors. An even better way of doing this is some botnets use domain names, right? They build in resiliency into their botnet. So what happens is the bots don't just refer back to an IP address for a command and control server, they refer back to a domain, and then they get resolved to one of many command and control servers. So that if you take down one of those servers, there's some resilience in the botnet. By taking down and deregistering the domain name, you now are rendering basically the whole botnet unusable. And now the bad actor has to go back, try recompromise the instance, get back inside, update the code so that it's pointing to a different domain, and it's a big cost for bad actors. We've been doing this now for a while. We were recently in the news for this. This article, you could probably just find it online, is speaking about how our intelligence is providing and supporting our ability to clean up the internet by taking down infrastructure. And also, it speaks about a feature and a service that we run called MadPot. MadPot is a network of honeypots that we use, and that gives us this capability. For example, remember the proxy-based infrastructure? We have these honeypots that pretend to be proxies, and so that when a proxy attack happens, we are able to be that little man in the middle. We are not forwarding on the traffic, obviously. We don't want to make the world a worse place. But we are able to have now a point of view that shows us where these proxy drivers are. And that allows us to take down proxy drivers too. So we're disrupting bad actors for proxies, and we're doing it on botnets. And here is some interesting stats on a proxy that by using these honeypots, we get some insight into how many attacks these proxy drivers are launching. This is just one example of an attack that was sending a proxy driver that was sending like more than 400 attacks in a day, which is crazy. So as we took it down, you can see the attacks fading away. But we're doing this all over the place. We're doing this. We talk to many ISPs. These are some of the ISPs that we see that have proxy drivers hosted on them. And they are partners of ours. We work very closely with them. We've had great success in doing this. And it's definitely, I like talking about this because if you happen to work for one of these ISPs, I'd love to talk to you. Because we want to work more closely with you and be able to disrupt bad actor infrastructure. All right, that is how we protect our infrastructure. I'm going to hand it over to Tazuri, and he's going to run you through how the responsibilities are shared.
Thanks, Paul. So Paul covered everything you benefit from while you run your workloads on AWS and how we help you protect against DDoS attacks without you knowing about it or doing anything really. But like every security talk, security is a shared responsibility, meaning that DDoS protection is also a shared responsibility. And besides the things that AWS does to protect your applications and protect our infrastructure that you're using, there are a couple of things that you need to do to make sure that you're resilient against these upcoming DDoS attacks. And they are, a fact of the internet. They will just happen at some point to everybody. So much like Fight Club, the first rule of being resilient or being ready to defend yourselves against a DDoS attack is to be properly architected. A well-architected review guarantees, or not guarantees, but it makes sure that your application is built in a way that allows it to withstand scale events. Not indefinitely, but to a point. So a good, resilient architecture starts with building your applications, building your infrastructures in the right way. This has nothing to do with security specifically, but it does requires you to be aware of what is a well-architected application, right? So follow this QR code if you're not acquainted with the well-architected program that we have. It's basically a way for you to make sure that you're following the rules, or at least you're aware of the rules that you are not following, and create a backlog item to fix those. Make sure the application is well monitored, it's scalable, right? Stateless where possible, scalable, automatic, so auto-scaling or using serverless components that scale out of the box automatically, and obviously make it secure. And we'll be focusing on what it means to make the application secure. When we're speaking about architectures, there are like different types of applications and different things you can do to protect these different types of applications. And we'll be focusing on 4 different architectures for 4 different types of applications. First, let's talk about these on-prem applications that you're using. So not all customers run full-on AWS. Some of them still have applications that run on-prem. And this is a good place to remind everybody that the CloudFront, Amazon CloudFront, our CDN service, well, it's a proxy service, right? It's a reverse proxy service, and it doesn't really care where the application resides functionally. So if you still have web applications, so HTTP-based applications or APIs or whatever it is that carries HTTP traffic, and you host it somewhere else, not on AWS, a good place to start protecting those applications is to put CloudFront in front of them. Basically, pulling traffic in towards CloudFront will benefit from all of the good things that Paul mentioned before, as well as allow you to enable extra controls, such as Shield Advanced and WAF, that we'll talk about later, regardless of where your application resides. Right? So if your application runs on-prem or on some other cloud vendor or hosting provider, you can always use CloudFront to protect these applications regardless of where they run. Obviously, if they do run on AWS, we'll talk about that a bit later, you can do more. When we talk about serverless applications, these are applications that typically will use some sort of an API service. So it could be your own homegrown Ingress APIs. So it could be ALBs running some listener. But specifically speaking about serverless applications, you'll see API Gateway, you'll see AppSync. These are 2 services that can carry AWS WAF on them, and you can protect the incoming traffic with WAF. So the infrastructure part is being taken care for you, right? That's the whole point of using serverless components. But the security part is still your responsibility. So enabling WAF on top of these services still makes sense. If you are well aware of API gateways can run in an edge-optimized way, right? Meaning they use CloudFront under the hood, or, well, it's the hood. But you don't control CloudFront for these edge-optimized API gateways. And if you enable WAF on top of an edge-optimized API gateway, WAF will be enforced in region. So if you have DDoS in mind and you want to take advantage of everything that our edge services bring to play, you can probably just enable your own CloudFront distribution to top API gateway, and then you control where WAF is, and you can assign your WAF web ACL to CloudFront, as well as to the API gateway, or just to CloudFront, if it makes sense to you. Most customers will be fine with managing WAF on top of CloudFront, and that's it. For non-HTTP traffic, we have still applications that don't run HTTP. They cannot benefit from CloudFront. CloudFront is a strictly HTTP reverse proxy, but we still have edge services, Paul mentioned them before, that can deal with non-HTTP traffic. Namely, we have Global Accelerator. So Global Accelerator runs at the edge. It receives traffic through the same networking mechanisms that Paul mentioned before, and it forwards traffic at layer 3 and layer 4, right? So we do things at the TCP level with Global Accelerator, and if your application is exposed through an elastic IP on an NLB that listens to random, not random, but your own specific protocol, non-HTTP, you will still benefit from Global Accelerator, protecting you against some vectors when it comes to DDoS mitigations. When we talk about Shield, it will even make more sense. And lastly, if what you're running a web application on top of AWS, that's like the classic use case. Always, always, always run your web applications behind CloudFront. It will make them faster. It will make your data transfer out costs lower. It will make them more secure. There is hardly any reason, and I'm willing to argue with anybody thinking differently, there's hardly any reason why you should expose a web application without CloudFront fronting it. Right? So that's like the last line I'll have about architectures, but it's the most important one. If you have a web application running on AWS, always, well, 99.9% of the time. There are some corner use cases, but most of the times, almost always, use CloudFront to hide that application. I'll give you a very quick example of why it makes sense, besides making it faster and cheaper. As Paul mentioned, CloudFront only processes web traffic, like valid HTTP requests. So random internet noise, which is like 44% of DDoS attacks, but it's just noise, like SYN floods or TCP floods, port scans, IP scans, it's just noise, you stop caring about completely, right? You don't see those types of traffic patterns anymore. More than that, even traffic targeting just random IP addresses that just happen to belong to CloudFront, if they don't carry your host name, your application name in the host header, we don't even refer that specific request to your CloudFront distribution. So you can make a short experiment. Like you can run an ALB in VPC and just put WAF on it and look at the logs. You'll be seeing a ton of traffic just sending IP addresses in the host header. Again, this is just the effect of the internet. So you will be found, you will be scanned, you will be found, and if you're vulnerable, you will be attacked. Using CloudFront, this random scanning of IP addresses in the internet gets filtered out for you. So CloudFront makes sure that only valid HTTP requests that carry your application name in the host header will be processed by CloudFront and attributed to your application. But then you can enable WAF on it and make further configurations in order to protect your application. So if there's one thing you remember from this talk is use sunscreen. No, use CloudFront. OK. So let's talk about more in depth about these two services that I've been mentioning on and on, WAF and Shield. And we'll start with WAF. So AWS WAF is an add-on service, right? You add it on top of another service. We have 7 services today that WAF can be enabled on. And it's basically acting as an attribute to the underlying service. So if you have a CloudFront distribution or an ALB or an API gateway or an app sync, all the list here, you just attach a web ACL, which is the WAF policy, to these services, right? It doesn't add almost any latency, right? We typically say a single-digit millisecond latency when you add WAF, so hardly measurable. It doesn't add any kind of networking complexity. We don't add hops. You don't have to install TLS certificates. It's just enabled on the service that already processes your traffic. So super easy to do. What does WAF do? So AWS WAF is a list of rules. Some are managed, some are custom rules, and we'll talk about them in a bit. A request comes in. It hits the web ACL. The web ACL has a list of rules, and they are processed in order. So if you have a specific rule that allows traffic in based on, let's say, an IP address, all of the other rules are irrelevant for that specific request. Then whenever you hit a rule, a terminating rule, either allow or a block or anything else, the decision is made for that request, and it's either dropped or being let in. So we can have multiple rules in your web ACL, as little as 0 rules or as many as pretty much you want that make sense for you. And each of these rules has certain match conditions, right? So it could be a simple match condition like a source country or a source IP. It could be a very complex match condition, such as a specific element value in the JSON body in the request. Or it could be a combination of these conditions. So it could be something like, if a request is not coming from my corporate IP and the JSON element called username contains the value admin, block the request. Right? So you can make these WAF rules as complicated or as simple as you need. Some of these rules are managed for you, and we'll talk about them in a second. WAF rules are tracked in multiple ways. They create CloudWatch metric blips. So whenever we hit a specific rule, there's a +1 on the CloudWatch map, and you know how many requests hit a certain rule in your web ACL. And you can also enable WAF logging, which logs everything relevant in the request. So what was the request? What was the request attributes? What kind of rules it matched throughout the processing in AWS WAF? What was the terminating action? What was the action that decided what to do with the request? Per rule, we can have a single action as a result for that rule match. It could be an explicit allow. If matched, then allow the request in. stop processing. It could be a block. Well, it makes sense, right? If a match, then block. It could be a count, meaning don't do anything special with a request, just flag it for further use. We can even label requests while processing them for other rules in the WebACL to take action on. And we'll talk about these labels later when we show an actual demonstration of how a WAF policy looks like. And it could be an active challenge. Like we can actively challenge the incoming request with either a JavaScript challenge or a CAPTCHA challenge. So a JavaScript challenge is a silent interstitial set challenge that we'll send to the browser. The browser, if indeed it's a browser, will solve it, come back with a token, and we'll let the browser in. Obviously, bots, specifically DDoS bots, they don't look at responses. They don't care about challenges. They typically don't know how to run JavaScript. So active challenges can typically kill a DDoS attack, but there's a better way to do it, and we'll talk about that. But this is another countermeasure you can use. CAPTCHAs, they test for how human you are, right? So we have a built-in CAPTCHA mechanism in WAF, and you can use CAPTCHAs to discern suspicious traffic, whether it's been driven by an actual human or not. Again, you can use these kind of controls in mitigating DDoS attacks, but there are simpler ways to mitigate DDoS attacks. That's what was like the 101 of what AWS WAF is. As we said, as Paul mentioned, this is on average a 200 level talk. So this was like the 100, 150 level. Diving deeper. When we talk about managed rules are rules that you can implement in your AWS WAF, WebACL, but someone else is managing for you. Most of these rules are AWS managed rules. Most of these AWS managed rules are free. You just choose what rules to add. Specifically speaking about DDoS, we'll see IP-based rules, so IP reputation, anonymous proxies. These are lists that our friends in Paul's teams populate, and we allow you to use. So you can decide if you want to block bad IPs, known bad IPs, if you want to challenge them, if you want to rate limit them. These are things you can do. But obviously, WAF being a WAF, you can use WAF-based rules, so more application vulnerability kind of rules against Log4j, SQL injection, cross-site scripting, but this talk is about DDoS. Of the managed rules that we have, some are paid. The most specifically relevant for this talk is the bot control rule, which tracks different types of behavioral anomalies in incoming traffic. Very simple ones, such as the source IP or user agent, and very complex ones as how different are the requests I'm seeing from this session from all other requests I'm seeing from normal sessions. So it's a very complex set of controls and rules. You can enable that, again, to mitigate the risk of being DDoSed, right? That's bot control. And there are partner rules as well you can add into our WebACL. We have partners that allow you to take their IP, their security rules that they have curated and researched and created, and you can easily implement them with a check of the box into your WebACL. And then you can benefit from our own IP intelligence rule set and another vendor if you'd like to. When it comes to custom rules, so as mentioned before, you can set pretty much any condition you want to match on. Once you have a match, you decide what you want this match, how do you want this match to affect your traffic. So either allow, block, count, challenge, or CAPTCHA. You can also enrich your requests. So if you're not sure what to do with these requests and you want to create like a soft rule, you can choose to only count on a match, but also add a custom header into the request to allow the downstream application to do something about it, right? So you can have your own custom logic in the application saying, hey, this is a bad IP, or at least I think it's a bad IP, do something at the application level. Don't allow it to do any checkouts or signups. And as a subset of custom rules, you're also allowed to do rate-based rules, which basically do the same thing, right? They match based on a criteria or a set of criterias, but they only do it after a certain amount of requests have been aggregated from a specific attribute. Namely, if a single IP has done more than X requests within the last 5 minutes that match that specific criteria, act on it. Act meaning block it, challenge it, count it, capture it. You can also create rate-based rules for non-IP keys, basically meaning I don't want to count per IP. I want to count how many post messages I'm getting across my entire footprint. So I'm only allowing 5,000 post messages towards my application because otherwise I know my database will tip over. So you can also do rate-based rules based on non-IP keys, count other things. One of those things you can count is how many requests I have in flight or in the past 5 minutes that were labeled a certain way. Remember these labels we mentioned before. And we'll see that take effect when we configure a proper WAF policy against DDoS. So we'll be using labels that a managed rule emitted, namely the IP reputation rule, and we say if we're seeing more than X requests from bad IPs, we start blocking bad IPs. Until then, it's just a trickle, it's internet noise, I don't care about those. One other thing we have introduced pretty recently, I think it was like 2 weeks ago, or maybe 3 weeks ago, we introduced an easy-to-use built-in WAF dashboard. It's baked into CloudFront directly. CloudFront has a new security tab that allows you to enable WAF right from within the CloudFront console. It allows you to enable logging from within the CloudFront console. It's very easy. I wouldn't say one click, but a 3-click solution maybe. And part of that new solution is the built-in dashboard. This built-in dashboard shows you automatic metrics like top IPs, top countries, top URIs, top matching rules, all the things you need to know about when you start using WAF so you can tune your configuration. It also provides you with fraud and bot control specific dashboards if you're using these advanced WAF features. So how many of your requests were bot requests? How many were successfully challenged? How many were successfully captured? That kind of a thing. They all appear in these built-in dashboards. As mentioned before, you can use WAF logs to create whatever dashboard you want yourselves, but these built-in dashboards are a perfect place to start. Let's talk about our DDoS-specific service super shortly, and we'll move on to the actual screenshots of what you can do with WAF. So for customers who know the value of getting DDoSed or getting downtimed because of a DDoS attack, we have a premium subscription called Shield Advanced. It does provide you with a number of benefits, such as direct contact with our Shield response team, in case you are being targeted, or you got a ransom note, or you want to know what happened after the fact or during the fact. You can contact our team of specialists, the Shield response team, and have them help you understand what's going on. And if there's something that needs to get done in your configuration, they can jump in and do that with you or for you. It provides you with cost protection. So in case you're getting DDoSed, that might incur costs. You might have more logs. You might have more data transfer out. You might scale your instances. You might have more WAF hits. So these are all costs that Shield Advanced customers are insured against, and we can reimburse them after the attack. And one of the key things Shield Advanced customers are getting is the Layer 7 auto mitigation rule, which basically allows you to check a box and say, once you baseline my traffic, Shield Advanced, whenever you see an attack, like an actual attack that you identify as a DDoS attack, try and find out what are the parameters that are only attributed with bad incoming traffic. So if I'm seeing, like 9 a.m. today, I'm seeing like 1 million requests that I have never seen before over the last 30 days, like different request patterns, like they don't have a refer header, or they're hitting a specific funny URI or something like that, Shield Advanced will add rules automatically into WAF to block these attack patterns. So even if you have like a super distributed traffic, super distributed attack, where you have 1 million IP addresses all sending 5 requests, so no rate limit really can block them, if these requests are all looking like the attack pattern, that Shield Advanced patterns maybe, that Shield Advanced detected, they will get blocked at request 1. So Shield Advanced customers can enable that for their web applications, and then WAF and Shield communicate between themselves, WAF providing the metrics, WAF providing the telemetry of what is normal traffic, and Shield providing updates and changes if a DDoS attack is happening. Let's cover a few best practices, and then we'll dive into the actual UI. For AWS WAF, one managed rule is a key rule you want to be made aware of, and that's the IP reputation one. We are seeing DDoS attacks, getting matches like 95, 98% of the bad traffic is getting matched with our IP reputation. So it's a super effective way to say this traffic is bad traffic. Either block it or flag it, but at least we know about it. So if you can only manage one rule in your web ACL, you'll have to decide either a rate-based rule or the IP reputation one. But one of these rules, super effective. So the second best practice, rate-based rules, right? Super simple to implement. You set a number that you think is reasonable for a single IP to send traffic in the course of 5 minutes. Let's say 1,000 requests. Whenever an IP goes beyond that, they get blocked or challenged or whatever. But at least you know about it. And if your application is very geographically specific, only selling to people at the Christmas island, like very, very specific geo, use geo-based controls to reduce the risk of having bad traffic coming from all over the place, right? So you can choose to challenge any incoming request not coming from within the Christmas island or wherever your market is. This is more a specific use case, but some applications are like that. As for Shield Advanced, there is a feature called proactive engagement, which allows the SRT to alert you when they figure out you have an attack and there is impact on your application health. It does require that you configure a health check, but it's a super useful feature. It allows you to have an extra set of eyes watching over your application and DDoS posture. So you'll have to use actual health checks and enable layer 7 auto mitigation if you're using Shield Advanced. Now, what you're going to see on these next coming slides is a layered approach in using WAF rules to mitigate or protect you against incoming DDoS requests. So this is a list of WAF rules. That's an actual screenshot from WAF. You'll see each of these rules have a name. Some of them are managed rules, and you'll see an action next to each of them. So the first few rules, quite simple. I have a list of allowed IPs, my corporate NAT, if I trust my corporate workers. Probably I want to allow them in explicitly so they don't ever get blocked, especially if they're like QA people, pen testers, a simple list of IP addresses that I fully trust. I don't fully trust anyone, but in case you do. Then a list of blocked IPs. So that's a list of IPs you know are bad, and you don't allow them in because you have previous forensics from your application logs or whatever, right? If you know IPs that you know are bad, you can manage your own list or lists. You can also automatically populate them through API calls, and these IPs are blocked, are banned. The same goes for countries. If you have embargoed countries, or you know that you only serve traffic from specific countries, you can either have a block list or an allow list, your choice. You can even have an empty list here, ready to get populated in case you want to start blocking countries during attacks. The next set of rules, these are the managed rules, and they clearly say managed. So these are two IP-based rules. The IP reputation contains three categories of bad IPs. One of these categories is specifically named IP DDoS. It's set to count because it contains all of these proxies that we know about that are typically used during attacks. They're not always sending bad traffic. This is why this category is set to count, but we'll work towards how to use it properly during DDoS. And the other rule, the anonymous IPs, contain a list of anonymous IPs. It also contains a list of data centers, like hosting providers. It's not all bad, right? Not all traffic not coming within AWS is bad, I think. But it will allow you to discern if you're seeing an increase, an uptick in traffic coming from non-domestic IPs. That's an indication, and you might want to create a rate-based rule to block these incoming requests in case they go over a certain number. The next couple of rules are specifically dedicated to managing bots, both bad and good. You don't have to use that when you think of DDoS, but it is a good way to fine-grain control if you have like a low and slow kind of attack coming from sophisticated or not sophisticated bots. These two rules will allow you to either block well-known or suspicious non-human actors, as well as protect well-known good bots, verified bots. That's the second rule. Specifically identifying good bots, such as SEO engines, search engines, social media bots, and always allowing them in, never allowing them to get blocked by the subsequent 3 rate-based rules. And these 3 rate-based rules are all doing different things. So the first rate-based rule is sending a CAPTCHA challenge to all anonymous IPs, right? Only when I see a certain amount of traffic coming from anonymous IPs. So remember these rate-based rules that can match not based on an IP, but on a label. So we allow the anonymous IP list to label, to flag all incoming requests from Tor exit nodes, data centers, hosting providers. We're not blocking them. We're only flagging them. But this first of the 3 rules indicates that if we are seeing, let's say, 10,000 requests coming from hosting providers, this is a weird number, and I want to start capturing every single session that comes in from these IP addresses. Right? That's one simple use case for rate-based rule. And I will leave you with a couple of links that dive deeper into that right after these couple of slides. The next rule will basically start blocking. This is not a capture rule, but it's a block rule. All incoming bad IP reputation IP addresses. And I want to double-click into that specific rule that just show you how it looks. So we have a rule. It's a rate-based rule. You see there like the radio button flagged at rate-based rules. Specifically, I set it at 3,000. So I'm counting up to 3,000 requests coming from all IPs that were labeled as IP reputation. You'll see like I'm using a custom key here. I'm using the IP reputation label namespace, and I'm setting the action to block. Right? There are a couple of label types in that specific label namespace, so I can also scope down my blocking rule to only include the labeled called IP DDoS. So I don't use the other labels to match that specific rate limiting rule. Basically, it allows me to have a panic level of saying I don't want to block bad IP reputation requests unless they go over a certain number of overall requests. This is a screenshot from the Shield Advanced dashboard. You can see there's more than just protecting CloudFront distributions. You can protect Route 53 zones. You can protect elastic IPs, load balancers. But for application aware, so layer 7 enabled services such as ALB and CloudFront, you also associate a web ACL. This is part of the benefits of using WAF and Shield together. Once you do that, you can enable the layer 7 auto mitigation that we talked about earlier, basically allowing Shield Advanced to create WAF rules automatically during attacks. Once the attack clears out, these rules will be taken away after a few hours. But during the attack, rules will be created in your WAF policy to automatically match and block known attack patterns. Once you do that, your web ACL will have a new rule with a long, ugly name, and that's the managed rule that Shield Advanced manages for you. It's currently, like at the start, without being attacked, it only contains the list of known offenders, like the layer 7 known offenders, at a rate-based blocking rate. So again, it's a coarse grain control, but during attacks, it will get populated with more rules that you can match on. Finally, before I leave you with the links, you can centrally control all of these features, Shield and WAF, across the entire organizations. If you have multiple accounts, multiple resources in each account, you can control all of these at a single point called Firewall Manager. It allows you to enable Shield and WAF and specifically send out rules to all of the protected resources, all of your CloudFront distributions, all of your ALBs, and make sure that whenever someone spins up a new CloudFront distro or a new ALB, it automatically gets a default WAF policy that you set up, so you're not going to get exposed by accident. And I will leave you with that, so take a screenshot. These are five links that will allow you to dive deeper into everything we talked about, allow you to learn more, how to use rate-based rules, how to use custom keys, how to test DDoS on AWS. There's a bunch of good stuff to still know about it. And that's it. Thank you for your time. We'll really appreciate it if you can leave feedback for this session, NET201. Paul and I get paid by it, so really appreciate it. Thank you for your time, and enjoy your evening.